Hello and welcome. We'll be dealing with climate models and climate scenarios in the next lessons, and we'll look at where the data comes from and how reliable it is. In the 1950s, the American scientist Roger Revelle had already realized that, quote, human beings are now carrying out large-scale geophysical experiments of a kind that couldn't have happened in the past nor be reproduced in the future. It's all about getting a glimpse into the future. Scientists are no fortune tellers. They don't use crystal balls. Instead, they use climate models and scenarios. How are these climate models and scenarios developed? Well, Professor Joachim Marotzke, director at the Max Planck Institute for Meteorology in Hamburg, is researching processes in the ocean and the atmosphere, and has been for the past 30 years, together with research groups around the world developing climate models.
Man-made climate change is happening, and it will continue. This raises a question of how mankind deals with this climate change. And in order to make good decisions, we need to predict how the climate change will look in the future. And Niels Bohr famously said, predictions are difficult, especially about the future. So let us look at the existing predictions about climate change. For this, I have brought to you what the latest generation of climate models says about climate change in the 21st century. We have illustrated this change through the change in the global average surface temperature. Black is the past, red and blue the future, and the change is here shown compared to the late 20th century. At first glance, this picture is rather sobering because we have an enormous spread of predictions. Here in the lower section of the blue shaded area, we have a temperature increase of perhaps ½ degree Celsius in the 21st century, which really isn't much. At the upper edge here of the red shaded area, we have a temperature increase of about 5 degrees Celsius. This is a huge difference to today. And this would be an enormous challenge for mankind. So where does this apparently huge uncertainty in our predictions come from? To understand this, we must first of all consider where these predictions came from, how they were produced. And the most important thing here is that these two shaded areas, the red shaded area and the blue shaded areas, are based on very different assumptions of how mankind will react to climate change. The red curve within the red shaded area is based on the assumption that mankind will adopt no effective climate change mitigation measures at all. Greenhouse gas emissions, chief among them carbon dioxide, will continue unabated, as will the respective temperature increase. The blue curve, by contrast, is based on the assumption that mankind will adopt effective climate change mitigation measures no later than year 2020. Greenhouse gas emissions will be reduced, and very quickly and dramatically at that. The respective temperature increase will be much more limited. Now, this explains the difference between the red series of curves and the blue series. However, this still does not explain why the shaded areas around the curves are so broad. And the width of the red shaded area here corresponds to about 2.5 degrees centigrade by the end of the century, and that of the blue shaded area corresponds to about 1.5 degrees. This width, this uncertainty stems from the fact that different models make different predictions, although based on the same assumptions about the choices mankind will make. And to understand why different models produce different predictions based on the same assumptions about mankind's choices, we must first of all look at how a climate model works and what a climate model actually is.